We are Patricia, Bradley, Nick, and Julio, and we'll be talking about airborne wind energy systems for our final project in green engineering. In order to reduce greenhouse gas emissions from sources like coal and oil, alternative renewable energy sources like wind can be used. However, traditional wind turbines are costly. They can be $3 to $4 million upfront with additional maintenance costs. They have a limited efficiency at 59.3% and can take up a lot of space. Some rural areas have high electricity costs due to their distance from the companies. A way to fix this is to have a system that can be placed out in the rural area to provide electricity closer to home. A potential solution to these issues are airborne wind energy systems. There are two common types of airborne wind turbines. In a ground generator turbine, mechanical work is done by the aircraft, producing a traction force that is transmitted from the aircraft to the ground system through ropes. This motion produces electrical energy from the generator. In fly generator turbine, the rotors and generators are both mounted on the aircraft. The rotors on the aircraft rotate in the wind and produce electricity from the generator. This electricity then travels through the tether to the ground station. Traditional turbines can only be placed in 15% of land across the U.S. and are limited by the length of their blades. Typically, they can generate 5.2 million kilowatt hours of energy per year. Airborne wind turbines use 90% less material. This makes them cheaper to manufacture and easier to install. Also, since the aircraft is tethered, it can reach higher altitudes and generate up to 50% more energy. A startup company called Alteris Energies designed the Buoyant Air Turbine, or BAT. It flies between 1,000 and 2,000 feet, where the wind blows 5 to 8 times stronger than it does near the ground. It has a 30 kilowatt capacity, and the unit costs of production are around $350,000 or $12,000 per kilowatt produced. Some challenges to this technology include ongoing maintenance costs, since there are so many variables to these systems. There is very little cost analysis for this technology available to the public, though. Additionally, severe weather could destroy these turbines and damage anything below. The triple bottom line. In economic terms, flying wind turbines show the potential of lowering electricity costs in remote areas where people pay upwards of $1 per kilowatt hour to just 18 cents per kilowatt hour, as previously mentioned. In terms of the community, people would gain access to cheaper electricity. Also, through extra payload capacity, in the future, Wi-Fi networks can potentially be installed on these turbines. Finally, in terms of the environment, having flying wind turbines in remote areas would turn people away from coal, gas, and other unsustainable fuels to clean wind energy. In conclusion, airborne wind energy presents an opportunity to capture more wind and create more energy per turbine. The initial cost of airborne wind turbines are significantly cheaper than that of traditional turbines. However, airborne wind energy introduces a new set of challenges, but it would not be surprising to see them increasingly implemented in the near future.